Hello, I'm Stefan Graber. I'm the project leader for LXD, and today we're going to be looking at something pretty interesting, which is LXD's metrics interface and how you can set up a system to gather metrics coming from LXD, and then a dashboard that we published very recently, which makes it easy to see what's going on either on a standalone LXD deployment or all the way to a cluster. The way the feature works is we effectively have an API endpoint within LXD at /1.0/metrics, which implements the kind of standard text format for metrics. So that's using the Open Metrics standard. And in this case, we're going to be combining that with Prometheus as the time series database that will be used to go and scrape that data from LXD and store it in the database, and then Grafana as a dashboard graphing tool of sorts to actually display the data and extract useful information from it. Here I've got the documentation for the feature open. The effectively instructions on how to generate certificates that can then be trusted by LXD for use for metric gathering. What's interesting with that type metrics option that we have on the certificates is that it lets you generate a client certificate that can be handed over to something like Prometheus, which can talk to LXD, but can only talk to the metrics endpoint. Those credentials are not otherwise valid against LXD, which is quite convenient from a security standpoint. There's then instructions on how to configure Prometheus to actually load up those generated credentials, and then scraping from LXD with I believe the default scrape interval from Prometheus is probably around 15 seconds or so. Now, let's get started and set that up and just see how things look. So here I've got a simple system. Again, that's Ubuntu 20.04, so it comes with LXD 4.8. Gonna be switching that to latest, and then do a simple LXD init. In this case, because I'm gonna want to be able to reach the both Prometheus and Grafana easily from my machine, which is not the same as the system I'm playing with right here. I'm gonna be configuring network through LXD init so that it can, so that it's on the same network, like on the parent network, so I can directly access it. Anyway, I'm gonna be doing that through LXD init. So just running that, it's generating the certificate, and then okay, no clustering today. Storage doesn't really matter, I'm just gonna keep the default. And then for the network configuration, so I'm not gonna be creating a local bridge. Instead, I'm gonna be consuming an existing bridge, in this case, BR0. And that's pretty much it. At this point, I'm just gonna be launching a few instances. So it's a simple Alpine instance. Maybe do an Alpine VM. And then, I don't know, like an Ubuntu container maybe. Actually, maybe the Ubuntu container while the VM is getting set up. That's just gonna saving a bit of time here. It's Nako1 in our mouse lab. And launch Ubuntu 20.04 container. So the idea there is just to have a few things running. So we can first look at simply the raw data that the metrics API exposes, and then can set up a container to run Prometheus and Grafana inside it and configure everything to play nice together. Just a few more seconds for that container to be done. There we go. Okay, and right. Forgot that Alpine regular secure boot be disabled, so I'm just gonna secure boot false, set on that, and then start it. So at this point, I'll actually close that second channel there. At this point, we're running those 3 instances. The VM is still starting up. We've got a container, and well, 2 containers, 1 Alpine, 1 Ubuntu. There you go. Got VM and container, everything's running. So you can already, like on any modern LXD system, you can do LXD query /1.0/metrics, and that gets you the raw data. So you can look at amount of network traffic, memory. There's a bunch of stuff around disk usage, more information about disk IOs, and then the CPU usage. But it's pretty raw, pretty hard to figure out for yourself, but that's the raw data that you can then put into something like Prometheus. With that done, let's create a new container. So can I create a new 2004 container, call that metrics. Actually, I meant to use the larger official Ubuntu image for it, because we're actually going to be using snaps, so might as well get the image that's got it pre-installed. So it's going to be downloading that one. And in that container, we're going to start by installing Prometheus, connecting Prometheus to LXD so that it can script data. And then Prometheus will be doing that in the background for a little while we set up Grafana. And by the time Grafana is set up, we should be able to have it, well, we'll have some historical data already to see some data points. But I'll also be showing another instance of all of this that I've had running for a number of weeks now, which can show a lot more historical data. It's a bit more interesting to see kind of an overview of a more complex environment. Alright, so let's go into metrics and need to install. So I'm going to be installing the Prometheus snap. It's not quite ready yet. Okay, fine. Now, reason for that is that gets us a modern enough Prometheus. The one that's available as a package in Ubuntu 2004 is too old for it to work properly. You need 2.22 at least. So that's getting us 2.28, which is sufficient here. Then the next step we need, if we go back to showing the instructions, is that command here for OpenSSL that creates a key pair. So I just did that. Now if we do a directory listing here, you can see that metrics cert, metrics key, and metrics cert needs to be added to LXD. So in this case, what I'm going to be trying to do is actually just put it directly. So if we do that, that will just get it onto std.out, and then I can do just add, and that's type metrics. Oh yeah. This is not using a token, but alright. Name Prometheus. Okay, fine. I don't know the actual file. Oh, I know what the problem is. There we go. I just forgot to give it the actual file name. Alright, so given that, we now have a entry in the trust store for metrics. So it's metrics type credential called Prometheus. The command name is metrics.local, and that can then be used to interact with LXD. What we're going to be needing is we're going to need the LXD certificate itself. You can either get that through LXD info, or you can just look at it from disk. In this case, it's going to be here. And I'm going to be putting that into the instance. The other thing we need is LXD can be either configured to just listen on the network for everything, or you can also set up a separate listening address just for metrics. So let's do that here. So let's do metrics address, and I'm gonna say that 8444 is gonna be it. So connecting to that port, just getting the IP address here. Okay. So from metrics, I can connect on this 8444, and that's working. So now we're gonna just need to write down the server certificate. Okay, if we go back here and look, now we've got metrics cert, metrics key, server cert. So that's all three certificates that Prometheus is gonna need. And now it's time to follow the rest of the instructions to actually put that all in place. So to add the target to Prometheus, first of all, it says to configure the listener. In this case, I used the alternative, so core metrics address here. And then it's Prometheus as a deb. The instructions can apply for /etc Prometheus because we're using the snap. It's instead the snap Prometheus current. And here we can just create a directory called TLS and go and move metrics star and server sub into there. Okay. So we can see here that I've got, oops, actually I moved them to the wrong location. We just fix that. So I'm just moving them into the, okay, there we go. I'm just moving them into the TLS directory here. So now we've got all the keys in there, that's very good. And the next step is to configure, first of all, give Prometheus access to that, but that's never mind, that's not needed for the snap. If you're not using the snap, you need to ch on the thing to Prometheus, but the snap effectively runs as root, so you don't need that. And the last step for Prometheus is to actually modify Prometheus YAML, which is its config. So you can see that by default it will scrape for every 15 seconds. It's got a whole bunch of kind of examples for a bunch of things. In this case, the only thing we need to do is add a new script config down there. I'm gonna copy paste what I've got in the documentation here. So that adds a new job called LXD, that's script/1.0/metrics of HTTPS from, and there I need the IP address of my host system, which I don't remember now. So it's local1 lab mas. Okay, so it's that address. Okay. And so the port was set to 8444 in this case, I'm changing that. And then the CA file is actually going to be server.cert, metrics cert, metrics key. So that's all good. There's an extra key that needs to be set in this case because the certificate that LXD uses will probably not include that address. So we can try, maybe it does. If it doesn't, then you need to effectively allow for insecure scraping, insecure TLS scraping in a TLS config. But let's give it a shot. So I'm just going to put that in place and then restart Prometheus. And I need the address of this thing. So Prometheus is 1990, I think. There we go. So now I've got the Prometheus web interface loaded, and I can go into status targets. And okay, we can see that it managed to scrape Prometheus itself just fine, but couldn't do LXD because of a certificate issue. So that was kind of expected in this case. There's a TLS verify option that we just need to set in this case. I'm just looking up the config, TLS config, insecure skip verify. There we go. All right, so editing the config again, we just need to go in TLS config and add insecure skip verify true. And let's restart Prometheus. And this time around, it should come back up and then be able to actually script things. We see unknown at this point. LXD is up and it's gonna script itself as well, just for extra metrics, but that doesn't matter too much. But we can see that the LXD one is now being scraped. That means that we should have metrics already captured by Prometheus. Right now it won't have much historical data, so it's not very useful. Also, directly querying through Prometheus is not super pleasant. That's what Grafana is really for. So let's go and look at that. Here are the instructions on Grafana's website for installing on Ubuntu. So we're going to be following that and use the repository in this case. So we're going to want the open source edition. There's no need to use the enterprise edition. So I'm just going to be literally copy pasting that stuff in here. Okay. Then adding the repo, which failed because, okay. That was just but copy paste. And then we should be able to do an apt update. And then finally install Grafana itself. Okay, it's complaining a bit because I ran all of the instruction twice. So I've got this entry twice in here. I'm just going to clean it up. Make sure that apt is happy. It is. And just install Grafana. Once that's done, then we can... Don't remember if it starts automatically or if we're going to need to make it start, but let's enter its address already. Just waiting for the install to complete. It is a reasonably large package. Come on. And it's probably worth noting too that like the other reason here for using, okay, so the thing does say to run, that it doesn't start it on install, you need to enable it. Okay, so it's just rerun the instructions that it's giving us. So enable Grafana server and start it. The reason for using their repo instead of what's in the Ubuntu archive here is that the LXD dashboard requires Grafana 8.4, which is very, very recent and not in the Ubuntu archive. Okay, so now I'm connecting to Grafana, so it's the IP address on port 3000, and I get the login screen. By default, I believe it's admin, then it asks to change the password, so you can just pick something. And then you're in the Grafana interface here. Go look at the dashboards, there's nothing, but we can easily fix that. So as I mentioned, we've got an official dashboard for Grafana. And if I switch to the right page here, that's the listing in the Grafana dashboard store, or whatever they call it. We can see here it's the LXD dashboard, overview of LXD instances, and it's got some screenshots to show kind of what to expect. And to import into your Grafana, what matters is the ID that's here on the right. So in this case, it's 15726. Going back in Grafana, I can just do import, enter the ID 15726, load, and that actually won't work because we need to set up a data source first. Sorry, I forgot about that. Grafana needs to be connected to Prometheus so that it can actually get the metrics. So going into the settings, data source, add data source, select Prometheus. In this case, it's localhost 1990 is good. There's no authentication or anything, so that should just work. Save and test. Data source is working. So now we've got a data source. Going back into the dashboard list, do browse, import 15726, load. And now at the bottom here, we can choose the data source, select Prometheus, and import. And here we go. So that's the LXD dashboard here in Grafana. It supports running multiple LXDs that would be defined as different jobs here at the top. In this case, we just have the one, so LXD. It also supports projects. In this case, there's only one, it's the default project, so it shows that. And then you can filter by instance within the project if you want to. And at the top, it shows the CPU usage by instance, memory, and rootfs usage. And you can change that as well to show either just, just the top 3, or you can go as high as like a top 15 or something like that. Obviously, in this case, when you have 4 instances running, so it's a bit limited use. The CPU usage here is in seconds of CPU time used. So we can see that A2, which is the Alpine virtual machine, used a bit of CPU. The first 2 containers never really did anything, so they didn't even use a full second. And metrics has been using a fair bit because, well, that's the one we've been using. Same thing for memory and rootfs usage. We also get the accumulated disk reads and writes, which are not very reliable on when using ZFS like I am in this case, because ZFS bypasses a lot of the metrics in the Linux kernel, unfortunately. But the network side of things is good, so we can definitely see how much network we used so far on those instances. Down there, you get also project usage, memory usage, and those are like per instance, so you can, well, that's the accumulated usage, but more detail on exactly how the CPU is used. Memory is also filtered between like the used for cache, actual free memory, swap usage, etc. That's like all the project overview at the top here. So it's the overview of the entire traffic within the project. If you want to look at a specific instance, say we want to look at the metrics instance, they're all here at the bottom. You can expand one of them, and then you get for that one instance. So say you're looking at disk space used, it shows what mount it's related to, in this case slash. Network, it also shows the network interface name, so it really shows you the details for the instance. That's pretty much it as far as what we have. As I mentioned, this doesn't have a lot of historical data, doesn't have multiple projects, so it's a bit boring. So let me show you what we're running for another cluster. And this one has effectively three clusters all in the same Prometheus, each with a bunch of projects. So if we switch to, say, the infra cluster here, there's like a number of different projects. So if I take, say, core, then that gets me a lot of instances. I see currently the top 5, so I can see the CPU usage and memory usage for our top instances. It also accurately, in this case, records the disk reads and writes, network throughput over the configured period, which is the past 6 hours in this case. And then you've got the number of running processes, CPU usage over time, all of that stuff is all working properly. And same thing with the list of instances. So if I wanted to go look at the Prometheus instance and that deployment, I can expand it, can see its memory usage over time, kind of how things are looking at. We can see that the process list is extremely steady in this case. Same thing with the disk. So that's pretty much what we have at this point. The real goal for that dashboard is to make it very easy to look at a set of LXD servers or clusters and go through projects and find potential issues, potential problems, potential abuse, and see that first at the project level and then be able to drill down to a specific instance. It's all still very new. We only published this dashboard a few days ago. Now, if you want to do so, get some more pointers, we do have a forum post that will be linked down below, referring to the official Grafana dashboard, and that links the instance metrics page I've been following to set things up, as well as the actual entry on Grafana and some screenshots, and there's some community discussion below. I hope this was useful to you. It's really a nice way to monitor a whole set of instances without needing to run anything inside of the instances themselves to get that data. Through Grafana, you can also set up alerts on specific instances or on the project overview, so that should something go really wrong, you get notified and can go look at what's going on. This is a really powerful tool. We're looking at adding quite a few more things in the future, and definitely welcome your feedback either in the comment section down below or on the community forum, especially in this thread I'm showing right there. Thanks for watching. I hope this was useful to you, and I see you in the next video. Bye.